Your app runs on GPT-4o. One provider, one model, one point of failure. OpenAI goes down and your entire application dies, or you hit your rate limit and 40% of your requests just vanish. This is the same reason you don't serve your website from one machine. You put multiple servers behind Nginx. So why are you serving AI from a single provider? Today, I'll show you 5 load balancing strategies that keep your AI alive. Strategy 1. Round robin. The simplest approach. You cycle through providers evenly. OpenAI, Anthropic, repeat. It's dead simple and gives you even distribution across all your providers. But here's the catch. Round robin treats all providers equally when they aren't. It ignores cost, latency, and capability differences. That's where cost-based routing comes in. Strategy 2. Cost-based routing. Route to the cheapest provider that can handle the request. Look at this. GPT-4o Mini costs 15 cents per million input tokens. Gemini Flash costs 7 cents. Compare that to GPT-4o at $2.50. Most requests don't need the expensive model. This alone can save you 50 to 80% on your API bill. Simple requests go to cheap models. Only complex tasks hit the expensive ones. Strategy 3. Latency-based routing. Track the rolling average response time for each provider and route to the fastest one available. You keep the last 100 measurements and pick the provider with the lowest average latency. Strategy 4. Capability-based routing. Different models are better at different things. Excels at code generation. GPT-4o Mini is plenty for data extraction. Why pay premium prices for tasks a cheaper model handles just as well? Strategy 5. Weighted distribution. Give more traffic to your preferred providers. Maybe OpenAI gets 50%, Anthropic gets 30%, and gets 20%. You control exactly how traffic flows. Now the most important pattern of all fallback chains. When your primary provider fails, you automatically fall back to the next one in line. Primary, secondary, tertiary. This is non-negotiable for production, but fallbacks alone aren't enough. You need health checking with circuit breakers. Track error counts for each provider. After 3 consecutive failures, trip the circuit breaker and stop sending traffic there. Check again after a period. Now let's put it all together into a complete load balancer. The balancer class combines health tracking, latency monitoring, and budget management. It picks a routing strategy, balanced, cheapest, or fastest, and filters to only healthy providers. And you don't have to build all of this from scratch. Tools like Litel LM and OpenRouter handle multi-provider routing out of the box. But understanding these patterns is crucial so you know what's happening under the hood. Let's recap. Never rely on a single provider. Use cost-based routing to save 50 to 80%. Fallback chains are non-negotiable, and health checks with circuit breakers prevent cascading failures. Implement even one of these strategies today, and your production AI will thank you.